So let's start reviewing the group test. Start with number 1. Logically, that kind of makes sense to do the first problem first. Okay, so we have the absolute value of 3 minus n minus 5 equals 3. All right, so the goal here is to get the absolute value by itself. The way we do that is add 5 to both sides, and we're left with the absolute value of 3 minus n equals 8. Now that we have the absolute value by itself, everything in the absolute value could equal negative 8 or positive 8. So we're going to separate this into two separate equations, one of which is equal to positive 8, the other one of which is equal to negative 8. Next, get the n by itself, so we subtract 3 from both sides in both of these equations. So we have negative n equals 5, negative n equals negative 11. Divide by 1, negative 1. And we get n equals negative 5 and n equals 11. That is choice C. All right, number 2. Number 2, we've got u cubed plus 27v cubed. Okay, so I asked you all to memorize the sum and difference of cubes factoring. So the sum of cubes factors to a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So in this case, instead of a to the third power, we have u to the third power. Instead of b to the third power, we have 27v to the third power. So what we're doing is essentially replacing all of the a's with a u and all of the b's with a 3v. Now the 3v came from the cubic root of 27 is 3 and the cubic root of v cubed is v. All right, so let's go through and start replacing. U plus 3v, u squared minus a is u, b is 3v, plus 3v squared. Okay, so we've got u plus 3v times u squared minus 3uv plus 3 squared is 9, v squared is v squared. Okay, and the answer for that one would be B. All right, next let's move on to number 3. 20k squared plus 26k plus 6 divided by 4k plus 2. The very first thing that you always want to do in problems like this is see if you can factor anything out to make sure that it's all completely reduced before you do anything else. So if I'm looking at this, I know that on the top, 20, 26, and 6 are all divisible by 2, so I'm going to factor that 2 out. So when I factor the 2 out, I'm left with 10k squared, 13k, and 3. Same thing with the bottom. 4k and 2 are both divisible by 2, so I'm going to factor that 2 out, and I'm left with 2k plus 1. So now that we have 2's on the outside, we can cancel them. So what we're left with is 10k squared plus 13k plus 3 divided by 2k plus 1. And this is actually a long division problem. All right, so remember, the way that we go about this is we always look at the first terms. So 2k and 10k squared. So I have to multiply 2k by 5k to get 10k squared. So I'm going to do just that. 2k times 5k is 10k squared. 1 times 5k is 5k. All right, so from here, we have to change the signs of both of these to whatever the opposite sign is because we're subtracting everything in this row from what's above. 10k squared minus 10k squared, those both cancel. 13k minus 5k is 8k. Then we bring down the positive 3. Again, we want to look at what do we have to multiply 2k by to get 8k. So we have to multiply 2k by 4 to get 8k. And then again, we're going to multiply both of these by what's on top. 2k times 4 is 8k. 1 times 4 is 4. And because we're subtracting both of these, we want to rewrite these as subtraction. 8k minus 8k, those cancel out. And 3 minus 4 is negative 1. Since there's nothing left out here to bring down, This ends up being our remainder. So we put the remainder over everything that we are dividing by. Okay, so our answer is, we take the 5k plus 4, let's move this up a little bit, 5k plus 4 plus negative 1, so that's our remainder, over 2k plus 1. Okay, and you can also just make this a minus 1 over 2k plus 1, so that's the same thing. So that answer would be C. All right, let's move on to number 4. These are the problems that all of you love. Okay, y x squared z to the 0 times 2x squared y to the negative second z to the third all to the fourth power all over 2y to the negative second. Okay, so in this problem, the goal is to get everything as simplified as we possibly can. So to simplify, we want to combine all of the x's together, all the y's together, and all of the z's together, and we also want to get all of the numbers by themselves together. Very first thing that I want to do is get rid of these parentheses. So if we think back to PEMDAS, parentheses and exponents, those are the first two. So we have a combination of both of those things here, so that's what we're going to focus on. Okay, so nothing else is going to change here. We're still going to have yx squared z to the 0. And the difference now is that, again, we're applying this 4 to all of the exponents in here. It's like there's an invisible 1 here. 1 times 4 is 4, so it's 2 to the 4th. X squared to the 4th is x to the 8th. Negative 2 times 4 is negative 8. And z to the 3rd to the 4th is z to the 12th. Again, you're multiplying. All over 2y to the negative second. Okay, from here, we're going to, in the numerator, combine all of the terms that have the same base. So we've got only one y, so we're going to leave that alone. But we have the 2 here for the x squared, x to the 8th, and we're going to combine those. Remember, when you're combining all in the same line, you're combining by addition. So let's leave that y there. And then we have x squared and x to the 8th combined to be x to the 10th. Again, 2 plus 8 is 10. And then we want to do the same thing with the z's. Okay, z to the 0 power. Anything to the 0 power is 1. We can just get rid of that. Then, if we come over here, we can combine those two together because they both have a z as a base. This is a 2, not a z. So negative 8 plus 12, that would be 4. And then we still have this 2 to the 4th power. 2 to the 4th power is 16, so let's put that on the end as well. And then we have a 2y to the negative second. Okay, so next what we want to do is combine anything across the division line. So we can do 16 divided by 2, and that is 8. We still have this y here, and the y over here can combine with the y down here. Remember, now we're subtracting, so we end up with 1 minus negative 2. 1 minus negative 2 is the same thing as 1 plus 2, which is 3. Okay, and then we also have this x to the 10th, z to the 4th, and that looks like it.